This is not how they transport the heaviest mining trucks in the world. This is how they actually move the heaviest mining trucks. That transporter has 176 wheels. These massive transporters move everything from airplane parts to wind turbine blades. But what we're interested in is how they relocate gigantic mining machines like this one. Moving one of those absolutely massive mining trucks, the kind you see in open pit mines hauling around mountains of rocks, is a wild operation. You don't just drive those things down the highway like a regular semi. They're too big, too heavy, and frankly, way too illegal for normal roads. We're talking trucks that can weigh over 1 million pounds fully loaded, with tires that are taller than most humans and bodies the size of small buildings. That's where these monster 176-wheeler trucks come in. But before you even get to that part, the mining truck usually has to be partially taken apart. They'll remove the tires, the dump bed, maybe even the engine or other bulky components. Basically anything that can help bring the weight down and reduce the height. It's all about making the load more manageable and getting it low enough to clear bridges and power lines during transport. Now, those 176-wheeler trucks, they're not just regular trucks with a lot of wheels. They're these insane heavy-duty trailers, usually modular transporters that are built specifically to carry ultra-heavy oversized loads like this. Think of them like robotic flatbeds. Each wheel module is hydraulically controlled and they can steer independently, adjust height, and shift weight. You name it, they can do it. That's how they manage to carry something that weighs hundreds of tons without breaking the road underneath. But transporting something this big isn't just about the right trailer. There's a whole logistical dance that has to happen. First, the transport company has to get special permits from the state or even multiple states if they're crossing borders. Then they plan the exact route, down to the inch. They have to avoid low overpasses, weak bridges, sharp turns, and sometimes even entire towns. Sometimes roads are temporarily closed or modified just for the transport. Then when it's finally time to move, it's not just a truck and a driver heading out. You've got an entire entourage. Pilot cars go in front and behind to warn traffic. Police escorts might be there to manage intersections. Utility crews sometimes drive ahead to literally lift up power lines or remove traffic lights so the truck can get through. It's like a slow-moving parade of steel and strategy. And speaking of slow, these convoys crawl. We're talking 5 to 10 miles per hour, sometimes slower if the route is tricky. They can take all night just to go a short distance. It's expensive. Moving just one of these trucks can cost hundreds of thousands of dollars, but it's still cheaper and safer than trying to drive a 1.3 million pound behemoth down a highway. Once the load reaches the mining site, that's when the real assembly begins. Crews use cranes and other heavy equipment to put the truck back together piece by piece. That part can take days or even weeks depending on the complexity and the weather. Only after that can the truck finally roll into the mine and start doing what it was built to do, hauling insane amounts of earth. It's one of those operations that most people never see or think about, but when you break it down, it's like a giant mechanical ballet happening behind the scenes. And the same thing happens for front-loading excavators. Now, before we get any deeper, don't forget to hit that like button like these transporting behemoths are about to hit these roads. In a nutshell, the Komatsu PC8000 is one of the biggest hydraulic mining shovels on Earth. This thing isn't just large, it's colossal. Fully assembled, it weighs close to 800 tons. That's more than 1.5 million pounds of pure industrial muscle. But here's the kicker. There's absolutely no way a machine like that could ever be driven on a regular road. It's simply too massive, too wide, too tall, and way too heavy. So how do they get something like that to a mine site, especially when those sites are often in the middle of nowhere? Well, just like the last entry, they break it down. The PC8000 is shipped in pieces, huge, heavy pieces, and it usually takes anywhere from 15 to 20 separate truckloads to get all the parts where they need to go. Each of those loads can require a special trailer, sometimes with over 100 wheels, to distribute the weight. If it's coming from overseas, the parts first go on a cargo ship, then get transferred to rail or road transport from the nearest port, and sometimes the company has to build or reinforce roads just to get there. It's a logistical puzzle. Once everything finally arrives, the real fun begins: assembly. Now, these aren't like Lego that you can just slap together. Specialized teams, often flown in just for the job, handle the reassembly. They start with the undercarriage, the tracked base, and work their way up. Massive cranes are used to lift the heavy components into place. We're talking booms and sticks that can weigh as much as a house. All the hydraulics, electronics, and internal systems are installed and tested. From start to finish, this can take several weeks depending on weather and terrain. So why go through all this trouble instead of just building the machine on site or finding a smaller one? Well, because machines like the PC8000 are essential for large-scale mining. They're built to move hundreds of tons of material per hour. The efficiency they bring justifies the massive effort and cost it takes to get them running. And speaking of cost, just buying the machine will run you somewhere between $7 and $9 million. Add another million or so for transport and another $500,000 for on-site assembly, and you're well over $10 million before it scoops a single load of rock. Still, in the world of mining, that's a smart investment. The PC8000 earns its keep quickly, and because it's so powerful, it reduces the need for multiple smaller machines, saving time, labor, and fuel in the long run. So while the logistics are extreme, the numbers are eye-watering. It's all part of putting a true mining giant to work. Now, if you've enjoyed this video so far, please don't forget to crush that subscribe button. Transporting a tunnel boring machine is not your average delivery job. These machines are absolutely gigantic. Some stretch longer than a football field and weigh several thousand tons. They're built to chew through rock and earth and carve out tunnels for trains, cars, or water systems, often deep underground. But before they can get to work, they need to be transported to the site, and that's where things get seriously intense. Take the Hitachi Zosen tunnel boring machine, for example. You can't just stick one of these machines on a truck and hit the highway. They're too big, too heavy, and far too complex. So what happens is Hitachi Zosen builds them in pieces. The cutter head, the main drive, the backup systems, the conveyors, it's all disassembled and packed up like the world's most extreme IKEA set. Then the pieces are loaded onto massive cargo ships, usually from ports in Japan, and shipped to wherever the tunnel project is happening. If it's a domestic job, the pieces might go by rail or even barge, depending on the terrain. When the ship reaches its destination, the real logistical ballet begins. Each massive part is carefully lifted off with cranes and loaded onto specialized trailers, those long, multi-wheeled ones that move at a snail's pace. These trailers distribute the weight evenly and can turn tight corners with hydraulic steering systems. Sometimes roads have to be shut down, traffic lights removed, and utility lines lifted just to get one of these parts through a city. It's like moving a small skyscraper in slow motion. Once everything finally makes it to the launch site, it gets even more complicated. A huge team of engineers, technicians, and rigging experts work around the clock to reassemble the machine piece by piece. This process can take weeks or even months depending on the location and how complicated the setup is. And since much of it is done underground, that adds another layer of difficulty, but once the TBM is assembled, it's ready to start boring, and it can go for miles without needing to stop. Now, the price tag for one of these machines can cost anywhere between $50 to over $100 million. Just getting it to the site and assembling it can add another $10 to $20 million. But when you're talking about major infrastructure like subway tunnels or undersea highways, it's a cost governments and companies are willing to take on. Because once it's in place, this machine becomes the heartbeat of the entire project, one rotation at a time. Now, do you think there is a better and faster way of transporting and assembling these colossal machines? Let us know in the comment section below, and if you liked this video, hit that like button and smash that subscribe because it helps us grow as we are such a new channel. Thanks for watching, and we'll see you next time.